Welcome to Creative World. In this video, we will solve Chapter 2 Learning Assessment 2.7 related to bridge rectifier configuration. Read the scenario. Determine the peak output voltage for the bridge rectifier in given below figure if the transformer produce an RMS secondary voltage of 30 volt. What is the minimum peak inverse voltage rating for the diodes? This is the circuit diagram of given problem. Inside this network, a bridge rectifier is connected across the secondary of a transformer having RMS output voltage at these two terminals of 30 volt, and we have to find the peak output voltage as well as peak inverse voltage rating of diode. First of all, we will try to collect the given data in this scenario. In this case, RMS secondary voltage of transformer is given, which are basically 30 volt, and in this scenario it is also asked to find the peak output voltage of this rectifier. So in order to find the peak output voltage of this rectifier, first we have to convert this secondary RMS voltage into peak voltage, and we know that in order to convert any RMS voltage into peak voltage, we take the product of those voltage with square root of 2. So the product of 30 volt and square root of 2 will result 42.43 volt. After calculating the peak voltage at secondary side of transformer, we are able to calculate V peak output voltage using this equation. V peak output voltage will be equal to V secondary peak minus 1.4 volt. Here 1.4 volt are subtracted from the secondary peak voltage of the transformer. And why we are subtracting these voltage? We know that in case of bridge configuration, at a time two diodes conduct. So the potential barrier of these two diodes are added together. We are assuming these two diodes are silicon based. So the potential barrier of an individual diode is 0.7. The sum of these two diodes potential barrier will be equal to 1.4. These are also known as forward voltage drop of the diode. V peak secondary output voltage will be equal to V secondary peak voltage, that are 42.43 volt minus 1.4 volt. So V peak secondary output voltage will be equal to 41.03 volt. Now the second thing which is asked in this scenario is what is the minimum peak inverse voltage rating for the diodes. In order to find the minimum peak inverse voltage rating of diodes, we have to find the maximum peak inverse voltage that can appear across diodes in this configuration, and that maximum peak inverse voltage will be equal to the minimum peak inverse voltage rating required for diodes. In case of bridge rectifier configuration, peak inverse voltage across reverse biased diodes is calculated using this equation. Peak inverse voltage across a single reverse bias diode is equal to V peak output plus 0.7 volt. This equation is derived in another video. Link to that video will be given in description. Now we will enter the value of peak output voltage which we have calculated in previous step, that are equal to 41.03 volt. So enter the value of peak output voltage and add these values together. So peak inverse voltage across reverse biased diodes will be equal to 41.73 volt. These voltage are actually the minimum peak inverse voltage rating for the diodes. So this was all about chapter 2 learning assessment example 2.7. Thank you. See you again in next video.